Okay, so good evening, everybody.
Good.
Good evening.
Good evening.
All right, welcome again to another time here, and I hope that we'll be able to understand some things today. And I also hope that these numbers will stay to the end because we will be working. See, I'm ready to stay to 12. We'll be working on the project. We'll be working on the project, the ALX project. So once it's time for the ALX project, I will have to stop recording. So if you really want to know what you are copying and pasting, you really want to understand how it works, I will advise you to sacrifice to stay to the end. I just hope our batteries can hold. So, but first of all, we need to work on the basic concepts, how they work, how they relate, so that when we start working on those projects, we will not be lost. So the first concept we're talking about is the string. The string. A string in C programming is a sequence of characters. When we say characters, A, B, C, D, symbols, all of that. So a string is a sequence of characters terminated with a null character /0. The string is stored as an array of characters. The C string is stored as an array of characters. And the difference between a character array and a C string is the string is terminated with a unique character /O and 0. So a C string is an array, is stored as an array of characters. Now, just like an array, you can declare a string and you can also initialize a string. A string is actually it's actually an array, but it contains just characters, that is letters and other symbols. Whereas an array is a collection of what numbers. Now, there's one thing I want to call our attention to. It will help the way we think about it. It will help the way we think about strings generally or arrays generally. And that is, by definition, the reason for an array or a string is because to save our time, to save us the time of beginning to declare variables upon variables. So what we did now is to stack the variables inside an array. Let me save this. I need this. This was my thinking, my thought process in the printf. So I'm going to start a new one now. So guys, so that's just yeah. What I was about showing us is this: is that when we talk about string, some of us are still yet to grasp the concept in our heads. Why do we need to work with strings? Why do we need to work with arrays? Suppose we declare a string and the name of the string is v, for example, and then the size of the string is, let's say, 20. right? What we just did now, in another sense, in a different way of looking at it, is that we are here declaring a variable that contains 20 other variables. Take note, please. We are that contains 20 other variables, but all of these variables now, they don't have distinct names, but rather, what do? They just have one name, which is v. So I might say something like this. So I might initialize the string like this. So what this thing mean in another sense, if you think of it in a different from a different angle, you should know, like we said yesterday, that every element in this string has what? A memory address. True or false?
Mm.
So every element in this string has a memory address. And remember, every cell in the string is numbered with an index number. So if every element has a memory address, right, we could say something like this, that v 2, remember if I want to know the memory address of so we could say something like that. Hmm? Let's say this is what x. Let's say we have already declared a pointer. I'm just going somewhere. I'm trying to point. I'm just trying to pass a message across. So this is extremely valid. Think about it. Why doing this person? So this is extremely what valid. This is extremely valid. You could see now that what the value of this pointer variable will be what the address of this element, this address of L. Yeah, this address, the memory address of what of L. The memory address of L. That will be the value of this particular variable because it's a pointer. You know, pointer variables what contain the memory addresses of other variables, isn't it? So with that same logic, you could say that every element in an array is a variable. So an array, you can redefine an array. You can say an array, although it's not in your textbook, but you can say an array. You can think of it this way. It's a thinking pattern. An array a collection, is a collection of what? It's a collection of variables. It's a collection of variables stacked together under one name. Stacked together under one name. Are we making sense? Are we together here?
Yes,
Yes.
we are.
Okay. Please remember, guys, let's try to stay to the end because we are going to work on your project. We are going to work on your project, the three projects that you're going to have. We are going to work on your project this evening. I know you have places to copy and paste, but then we're going to work on your project. For those of us just coming, you're welcome. We have not really gone that far. So then, if you look at it, say an array is what? An array is that's a collection there. An array is a collection of variables stacked together under one name. So each of these variable we have their own memory addresses, right? So if this is a string, for example, of course, a string is also an array. A string is an array, but it's an array of characters. So if this is a string now, for example, you could see that we could access here, look, we could access what? This, the memory address of what? Of the character that is living inside this memory address in index number 2. So with this now, remember we said when we were talking about pointers that we could what? Change the value of the variable that the pointer is pointing to. So which means that if we change this to something like to O, right? This L we change to O. Please, this is an idea. I just want us to work on it individually. It's not what we are going to measure on today. We have other more more important things to do. I just want us to just have that in our mindsets to help our thinking, because all of this concept, if you don't break this concept down, you might find it difficult to start understanding them, to start using them. You might really find it difficult. So with that said, let us continue. Now we are going to talk about a couple of functions in that are used to manipulate strings. For example, the string copy function that copies the content of one string into another string. We'll talk about, I think they are in the slide. Let's talk about this function. This particular function finds the first character in the string that matches any character specified in the second string. So this is a tool. It's very, very important. Think about it. Let's say, for example, you went to buy a lottery ticket, and in your lottery ticket, right, you have the winning ticket. Do you understand? So you have the winning ticket, and inside the ticket, there's a particular character that will validate your winning, or that we be used to identify you as the winner. So during the lottery, you know what they do. I don't know what they do. I think when they start to look for the winner and all of that, search for the winner, your what's it called? The character in your ticket matches what? The character that they are looking for to identify the winner. So this can be done using this particular function. We'll do something like that later. You see it. So you can use this particular function to create, maybe you create a mobile application, and it's either for a game or maybe something, or maybe for a project in school or something that has to do with searching through an array of characters to look for the one that matches the particular character that you're looking for, just for the sake of carrying out a particular task. So you can use it's very important in programming. There are others that we'll look at here. Then also this one too. Say this one searches for the first occurrence of a particular character in the string pointed to by an argument. So we have quite some technical things to do this evening, and I really want us to be focused. So first of all, let us start with the simplest. I'll call it the simplest because it's really, to me, I think it's the simplest. I don't know what's going on with my mouse this evening. So let's start with it. When you're working with string, you need to include the string header file, which is string.h. So now the first thing we'll need, the first function we'll be learning here is called um, the string length function that is used to look for the length of a string. It is used to look for the length of a string. This is a function that is used to look for the length of a string. After that, we'll come here to work with the copy function. So it's very easy to use. Just follow a very simple logic. So let's say, for example, I create a string called s1 and I set the size to be 50, for example, right? So maybe I wrote something like this, right? So then, because we are going to look for the length, I can say this is any length, declare a variable of int, because of course this is going to give us a number, length. Now this is a string. Now I want to find the length. So what we'll do here is to assign the operations of that function that I just said now into this variable. We'll call the function strreal, and then in it we'll put what? We'll put s1. So once that is done, length now contains the length of the string s1. So we can then display it to know what it actually contains. Very easy. Easy peasy. And say the length of s1 is 3, right? So length, then return 0. So if you see what we did here, first of all, we created our string s1, we declared it, we set it to size 50, and then we initialize it with this sequence of characters here. Then we declared another variable called length of type int. that is to contain the length of the function, because of course when this function, the string length function, when it retrieves the length of the string, it is going to come out as a string. It is going to come out as a string. So that's why we had to what? Assign it into a variable of type int. Then we want to see it in standard output, and that's what we did here. And so that's it. So let's compile our work and see how that pans out. Please guys, hold on, we have lots of things today. We are going to talk about two-dimension arrays. Okay, say this expect argument of type char, length of blah blah blah. Sorry, mistake. So you can see here the length of S1 is 12. The length of S1 is 12. What's going on today with my mouse? I don't know. The length of S1 is 12. So guys, do you have any question before we go to the next? Is there anything not clear?
No.
Is it clear?
Yes, it's clear.
Yes,
Yes,
yes, it
it's
is.
clear.
All right. The next thing we'll do, we'll learn how to reverse a string. So what we'll do, we want to reverse that string. So please, I want us to pay attention because it's going to be a little bit, it's going to get a little bit confusing if you do not pay attention. So what we'll do, for you to really see the effect, because I don't want anybody to say, okay, maybe I did Ojoro. So for you to see the effect of what we did, let us use a very simple name. Let us say, let me use my name. Let me say, for example, Godfrey. This is my name, Godfrey. Now what we want to do is that we want to reverse this string so that when we print it out, it's not going to start from G, but it's going to start from the back words. It's going to start printing backwards from Y to G, so that the last cell of this particular string will become the first, and let me number it so I can know the number. So that 6 will be in 0, and 0 will be in 6, and 5 will be in 1, right? And 1 will be in 5, just like that. So well, normally there's a function for that, stro rev, but we're not going to do that because I think there's the ALX project did not ask you to do that. ALX project says you should do it yourself. They didn't ask you to use this particular function. So we are going to do that now very quickly. Remember, we are working with strings, different functions that are used to manipulate strings. So I'm going to reverse that particular string. See how it's done. It's not so difficult if you know how it's done. So first of all, if you remember, there was a time I think that we have done something like that in the past project, but I can't really recall. Anything that the algorithm of swapping reminds me of a scenario. The scenario is this: two cars are at a gridlock. They are facing each other in the same lane, in the same road, right? One is coming from the north. Let me show you what I mean. One is coming from the north, another is coming from the south. And then there's a third road. So this is lane A, right? This is lane B, and this is lane C. And that is lane C. Now, if A and B are at the gridlock here, what do you think what do you think they can do for them to be able to pass the road? For each of them to be able to pass through the road? Hello guys, any ideas?
One needs to go to C, so the other will go first, and the other one pulls out.
Okay, one needs to go to C, right? That means let's
Yeah.
say let's put this one, this is one, this is two. This car here is two, right? So car one entered C, so that, right, C, the car in lane A is assigned to what? To C. Are you following this? The car in lane A is assigned to C. So lane C now contains what? This particular car. So we can just still call this thing A. Whatever it is that is in A entered C. Do you understand me?
Yes.
So now
Yes.
A is open, right? So B now, what will B do? B
B
will,
will
Moving
go.
to A.
B will go to A. So that means that C now, because whatever it is that was in A, or this road A now, will be assigned to what? To B. I hope I'm getting this. I hope I'm not missing this thing up. Okay, sorry. B is going to go to A. Let me put it that way. The best way. B is going to go to A. If B goes to A, it's not going to be like this. It's supposed to be like this. B will be assigned like this. B will be assigned to A. Do you see that? So that A now
Mhm.
contains whatever it is that was in B,
B.
right?
Yeah.
Now, remember, whatever it is that is in C will have to move into B, right? For it to
Yeah.
Yes.
pass, for it to go to his way, so that what? B,
Is assigned to
yeah,
A.
so that C now will not be assigned to B. Do you see that? So that is the swapping. First of all, the two major actors here is A and B, but they needed a third place where they could breathe. Else, it's not going to be possible. I think with this idea, if many problems in marriages would have come to an end. Anyways, let's continue. That's not the bone of contention today. So we want to apply the same logic to the problem at hand here. I created a string. Let me say I created a string called x, and I set it to 35, for example, right? And I type my name there for free. Right? So now I'll have to what? I'll have to find a way to see how I could swap this. Now, if you look at now, if I want to swap y to g, and g to y, e to this, and this to this, this to this, can't we see that there's an action that is going on repeatedly until it stops?
Yeah.
Or didn't you see it this way? The action of swapping y here and g gonna come here, e here and o is gonna come here, arrow here and d is gonna come here, right? So it's an activity, it's a repetition. If this thing is so and so, there is a condition, there must be a condition, you understand me, for the swapping. So we are going to define that condition, and we are going to, that condition is what we use for what? The sequence of activities. And we know that whenever there's a repetitive sequence of activities, we use what? What device do we use? Hello guys, what device do we use whenever we think
We
about?
use loops until a condition is met.
Yeah, we use a loop. So in this case, we'll say that keep on swapping until you get to what? The middle what? Character, because the middle character will not have anything to swap with anymore. Do you understand? So we'll use a for loop, and we'll have to divide this particular entire array by 2, so that the middle, normally if you divide 7, 1, 2, 3, 4, 5, 6, 7 by 2, you will have what? 3.5. But then the way the computer recognizes it, when you have 3.5, the computer reads it as 3. You just take it as 3. I don't know why it's like that. Don't ask me why. I'm not a computer scientist. So we have 3.5. So what we'll do, we'll define an endpoint 7, which is the length. So let us go back to our code. So then we'll let's say this is length. Let's use this word as length, right? Declare those variables there. Also declare the last one that will be used to what? To breed out 2 rows. Are we together, guys? Is there any confusing thing here, so that we'll be able to straighten everything out? Now using the okay,
This int, are we having int I, comma, then int length too?
yes, I declared 2 variables now. I just declared 2
Oh,
variables
okay.
at once. Yeah.
Okay.
I is what we use for what? The for loop. Remember, indexes here, right?
Yeah.
Indexes are what defines the position of the element in an array, or the element in
Okay.
a string. This is an index. For those of us that don't know, this is an index. This is an index. So they are what defines the position in a string. Do you understand me? So
Yeah.
if you are going to do a for loop where you'll be iterating and iterating and iterating, right?
Yeah.
Yeah, you have to ensure that you link that loop that is counting to the positions in what? In your array, so that as the variable increments, right?
Okay.
This particular string will go to the next cell.
Okay.
That is why if you notice, maybe we want to represent this particular variable, this particular array now, we can just say okay, and we'll put I here.
Okay.
That's why we put I inside the braces. That's why we put I
Okay.
inside the braces like this. So you will see more of that as we continue. So, but then,
All right.
yeah, the indexes help us to know the positions of the arrays is used for that to track the positions of the elements in the array. So through the indexes, we're able to locate the memory address of a particular element in the array. Do you understand? So let's proceed
Yeah.
now. Okay, so let's proceed. So now what I would do here is to use that same the function we used in the previous example to find the length, right? The length of what? Length of x. Now this length is what we use to what? To define the endpoint for our loop. That is where the loop will stop the swapping. Please guys, pay attention because we're going to write some code that will require some little mathematics here. For I equals to 0, check if I is less than length divided by what? 2. So it's going to be like a midpoint. Check if I is less than what? Length divided by 2. Increment I. Now, remember the story we said just now about those 3 cars that were at the gridlock. About the 3 cars that or where about the 3 cars that were at a gridlock, right? So this is where this particular variable comes in. What we'll do now is to assign the first element when the index was 0. Look, index here is I. So when the index was 0, we're going to assign the first element of the string to what? To that variable. Are you seeing this now? So if we look now, the first element of the string is what? What's the first element of the string?
G. G.
G, G, G.
The first element of the string is this 0, G rather. So when I was equals to what? 0, this is G, right? So this G now will be assigned to the variable ch. This G will be assigned to the variable ch, so that ch now contains G. Are we following, guys? Now,
Yeah, yeah.
the next thing we'll do is to assign the last element in the last element in the string is to assign it to what? To the first position.
Sorry.
Okay.
Can you go back to the code, please? Can you go back to the code?
Who is speaking?
Samuel.
Okay.
You said you are assigning G to CH, right? So, but with what you wrote, it means you are assigning the whole array itself to CH.
No,
So I think it's supposed to be X. The bracket the 0 should be in the bracket, not I, since you are assigning to G.
no, Samuel.
Well,
Please, who can help him? Who can help him out, please, before we continue? I would, but I just want to, maybe I just want to believe that somebody understood what we did.
It's because we're in the first iteration of the loop, so I equals 0.
Okay. So if I is equals to 0, right? It means that we are in the first position. We're in the first element of what? The string. Look, we're in a loop somewhere. We're in a loop. I is equals to 0. So here now in this loop now, I imagine it to be what? 0. So which element is in that position of 0? Is G. G is in position of 0. Look at it here. G is in position of 0. So therefore, if you remember, that is why I started with the explanation that what? Every 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 element in a string or an array is a variable, but it's just more like variables that are stacked in a particular place but given a name. A variable stacked in a particular place and given a name. See, an array is a collection of variables stacked together under one name. Are we together, Samuel? So if we want to know, if we want to get a particular variable here, instead of declaring it or giving it a name by declaring it, all we just need to do is to what? Do this v, and then look, maybe you want to get d, and then look out for the index and write it here. So what it says is that what? We want to access what? The variable or the element that is in the fourth position, that is in the third index, which is the fourth position. Do we understand, guys? So now in our code here, this loop is going to iterate through the entire string. But because of the code that we're going to work here, it's going to end where? At the midpoint of the string. So the length of the string divided by 2. Now, for I equals to 0, which means that when we are at the first position, the first index in the string, the element G is represented by this notation X, then I inside the brace. Are you seeing? So we assign this particular variable now. This is a variable. We assign it to what? This variable ch. But it is not this particular thing. This is just a carrier, of course. It's the value that is here, the value that is in this particular, that is in the string at this particular time, which is 0. When I is equals to 0, it is G that is here that we actually assign. So you will not see the G physically, but that's what has been assigned to ch. Now, after doing that, the next thing we want to do is to assign the last element in this string to the first position. We want to assign what? The last element of the string to the first position. Remember, when we took this particular element that is in the first position to what? This variable, this particular position will become empty. So now we need to what? We need to assign the last element um, of the string to the first position. So let's do that now. So how do we do that? Remember, when we're trying to access the first element in the string, we use this particular notation, the index, which means that when I equals to 0, right? When I is equals to 0, when I is equals to 0, for I equals to 0, this element here, that is x0, the element inside x0 now is G. So for us to get the last element, we have to do something like this. X is equals to what? The length, the total length of the string, right? Minus 1 minus what? I. Why do we need to minus 1? Because why? We started from 0. The total length minus 1 minus I. So that will take us to the very last element. This formula will take us to the very last element. We can analyze it, maybe you can see. The total length of the string is what? 1, 2, 3, 4, 5, 6, 7. 7 minus 1 is what? 6. Isn't it? Isn't it, guys? 6 minus I is 0, is what? 6. So if this is x6, in this string, in the string, the index, when the index is 6, the element in that particular address, that particular cell is y. So let's continue. Maybe if there are any questions, then sorry. So after we've done that, the next thing we need to do now, that element that was in the first position before it was assigned to a third party element, this ch now, we want to assign it to what? To the last position. And remember, this particular formula here is what represents the last position. So the last position we receive the last position is going to receive the former first element. You see that? So we're going to come here now. Since we have done that now, I will explain that a little bit later. Let me just run this thing up. So you can see the reverse string is this. My name has been reversed. Is there any confusing part here? Is there anything that's confusing? Let's straighten it up. Please guys, quickly, we have quite a lot to do. Hello. Uh-oh. The time got finished in that one.
And I actually saw a message that that said it was going to end the call.
Yeah.
I was even thinking it was from my end.
No, it's not from your end.
Trying
It's Google. Google said we should pay if you want us to if you want to enjoy unlimited. Admit I joined in with my phone. Admit I joined in with my phone. It would have lasted longer.
Okay.
I use my laptop, but now I'm joining in with my phone now, so that's why.
Okay.
To join in again now, people will still come late.
Oops. A lot of people are ready to learn tonight.
Maybe we'll do a poll so that people would tell us the time that they will be available. It seems people are
That's because I sent the link to some of our guys also.
okay. That are not part of the group. That are not part of the group.
Yeah.
They should request to join so that we'll add them up.
Okay. I will send the group link to them also.
All right. Sorry to join. You're asking me a question if it's a new link. I don't know why Nigerians we just have this our funny. Okay, he sent it again. Okay. Let me join in with my laptop. What's going on? Can you just imagine? This guy sent a very wrong link. Okay, let us begin. Let us continue from where we stop. This is the correct link.
Hope you guys are still there, sha.
So we'll go through that code again so that we can.
Hello.
Yeah, we're speaking. We're
Hi,
here.
we are here. Hi.
Okay, okay. I thought my name was wrong.
All right, guys. So let us continue. So, guys, do you understand how we reverse that string? Hello, do we understand how we reverse the string?
No,
Huh?
No, the hex
no,
was
no, no, no,
broken.
no.
Okay. When I was doing it, the network. Oh my God.
Yes.
Yeah.
So I think
Do it
we
again.
stopped at ch is equal to x.
All right.
Um,
Okay. Now, what I said here was that by inputting this notation I, this character I, inside this array brace, we have linked our array.
Oh, sorry, please. Can Ahmed mute it?
okay.
Sorry.
So by inputting this particular character I into our array brace, we have linked this particular array X to what? To the loop variable here, this loop variable I, so that it becomes whatever the variable initializes to. Now, initially it initialized to what? 0, which means that what? X brace 0. When X is 0, when the index number of X is 0, the element in that particular position is G. The element in that particular position is G. This is it, 0. It's G. Let me clean all these things off.
Sorry, boss.
Okay.
Yeah, some of us are just joining. So as I'm seeing so many jaga jaga now, it looks like Arabic to me. It seems you've not gone far, but please, just for the benefit of some people like me.
We started by 8 o'clock or past 8. Now, what's the time? You mean we should bring an hour's work again? Back? Guy.
Chai. Yeah, no
The
problem.
highest I can do,
Just
the highest I can do is to do a recap. What we have done is not really so difficult. It's just this particular stuff.
yes, it's just a recap. That's what I'm saying. I
Yeah,
can pick from anything.
okay. What we said was that an array is a collection of variables that are stacked together under a single name, that is under one name, which is this jaga jaga you saw here, right? So, and we say that
Yeah.
a string is an array, but it is an array of characters. A string is an array of characters. Now, we say that when you um, when you declare an array and you initialize it to some string, you initialize it with some string, like in this case, my name. Let me say the name of of course, the data type of the array is this, of the string is this car. Let's say Y, that's the name of the array. And then we set the size to like 30. So then, these double quotes, when I type my name. Irene, what's the issue? I can't hear you clearly. Can you put your mic close to your mouth?
Can you hear me now?
Yeah, I can hear you.
So I was saying that how do we know the size that we can set our variable to?
It
Because
dep-
I
it
saw
all
last example
it all
35.
depends on you. It's at your discretion, but make sure that the contents of your string does not exceed the size that you have declared, because it will lead to what we call an overflow condition. And
Okay, thank you.
it's yeah. So then, if you look at this thing now, what we did here, we have just declared what? The array y. We set the size to 30, and then we initialize it with this string Godfrey. Remember, and I mean a string rather. A string is what is an array of characters. Now, a string is also an array. And an array is what? Is a collection of what? Variables. So you can also replace it to say a string is a collection of variables of type char that are grouped together or stacked together under one name. The logical representation of memory looks like this. So each of these particular cells represent 1 byte of memory, and they each have their own what? They each have their own memory addresses. For the sake of simplicity, to help our thinking, I think they invented what we call the index number that will help us locate the addresses of what? Of the elements in an array or a string. But that's not what we are here for now. It's very easy. We have done that yesterday using pointers and the unary AND operator. So we'll not go back there again. Maybe until later. Now, this is the index 0, 1, 2, 3, 4, 5, 6. Remember that what? Remember that our string always ends with what? A null. Always end with what? A null character. So the null character you write it there with your hands. If you don't write it, it's still there. So don't start asking, what about the null character? It's there automatically. Now, if we go back to our code, the code we're writing, we are trying to reverse this particular what? This particular string, so that the last element, which is y, will be found in 0, and the first element, which is g, will be found in 6, which is the last cell. And this element in the fifth will be found where? In e. In the in the second index there, which is 1, index 1, and the element in index 1 will be found in index 5, like that. Arrow will be found here, and D will be found here. So I didn't know there's a dog in my name. F is not going anywhere because it doesn't have anybody to swap with. So F stays here as a mid element. Now, because F is not swapping, so F is the endpoint. F is the endpoint because it's the point at which all the swapping ends. It's not swapping, so it's just there. So that is why we created it now in our code. After we declared our string and we declared other variables that will be needed, like the length and this I that will be used for the looping variable, and then this ch that will be needed for our swapping. We then looked for the length of what? Of the entire string using the string_length function, which we talked before now. It was the previous example. The string_length function. Using the function, we input this parameter. The parameter is what? Our string our string in question, x. Then we assign whatever value this computes to len. Now, because the issue of swapping, if you look now, this is an activity that we did here, a repetitive activity. G goes to, Y comes to 0, G goes to 6, E goes to 1, D and D goes to 5, and R goes to 2, and D goes to 4. So it's a repetitive task, and we all know that the device that is usually used for repetition is what? The loop. So we had to what? Bring in the loop. Now, because we are swapping, it was very important that we cleared our thinking. So that was why we talked about what? We use an algorithm that will help us understand how the swapping is to be done. So I brought out the scenario in this place. I brought out the scenario where two cars are at a gridlock. The first car is in what? Lane A. Let's call this lane A, and it's coming from the north. The second car is in where? Is in lane B. And then there's a third car here, and there's a third road here rather. So this is lane A, this is lane B. They are at a gridlock. No one for any of this car, for these cars to pass this road successfully, one of these cars must what? Must have to divert to where? Lane C. So which means that if there was no lane C, the diversion would not have been possible. True or false, guys? True. The diversion would not have been possible.
Yeah, true.
True, true.
So what we need to do, maybe if A would have to divert into what? Lane C. The car in A would have to divert into lane C, which means that A will be assigned to what? To C. So A has entered C. Then B, we go what? We move into the position that A was, that is into lane A, so that what? B will be assigned to what? To A. Then when that is done, C now, right? The car that is in C will go into B, so I can go his way here. So which means that what? C will be what? Be assigned to what? B. C will be assigned to B. So what we did now, we just did the swapping. You can use this for any idea you want to do. Use it. It depends on how creative that you are. Depends on how creative you are. So this is swapping algorithm. And that is what is needed in this particular scenario now. So then we want to apply it to our code. Now, for I equals 0, check if I is less than length divided by 2. If that is true, assign the element in this particular position. You see, this is a position xi, and what is I? 0. For I equals to 0. So imagine 0 here. Whereas the element in position 0, index number 0 is what? G. You see it here, G. So they are saying what? Assign G to what? This variable here, ch. Assign G to that variable ch. Then after you have done that now, we want to what? Assign the element at the last cell to what? To this first position. I want you to change your imagination. Let me stop even using theory. This place now, see it as 0. This is 0 because I is equals to 0. Are you seeing that? So what we want to do now is to do what? Is to assign the element that is at the last position. And to get the last position, we'll say length minus 1 minus 0. Sorry, minus I. I'm already, my mind is already getting used to that 0, which is the same thing as 0, right? I is equals to 0. So in this situation now, I is equals to what? 0. So if you calculate it now, the length is what? 0, 1, 2, 3, 4, 5, 6, 7. So 7. 7 minus 1 is 6. 6 minus 0 is 6. So the element in this particular position when when index is equals to 6 is what? The element there is y. Look at it, 6, y. So we are assigning 6 now. We are assigning y. We are assigning y to where? To 0. Are you following, guys?
Yes.
Yes.
So let me change this now to I, because it's I. I is equals to 0. I just did that so that you can really see how it's done. For those of us that are kind of confused. Now, after that is done, there's still something remaining, right? The last position is empty. We want to carry the element that was in the first position to the last position. Remember that we did not delete the element that was in the first position, which was G, but rather we stored it somewhere, CH. So we want to assign CH now to the last position so that the element that is inside CH will become the element in what? The last position, which is what? G. So how do we do that? We come back again to say what? The element is len minus 1 minus I is equals to what? CH. So we assign CH to it. Are we together, guys? So we assign CH to it. Now I want to print out to see how it's going to display. So you can see the reverse string, or you can just do it like that. This is not important. The reverse string is what? This, right? You can see. Can me. Will that give me a very resounding error message? So we can see the length of his name, or rather, you can say his name as what? Right. So we'll go gcc ref.c Okay. So the reverse string is this Yerf dog, and its name has 7 letters. So I think I've gotten a name I can use to create another channel on YouTube. The reverse string is Yerf dog, and its name has 7 letters. So that is how to reverse a string without using the particular default function. Any question, guys? Hello, guys. Feedback.
Yeah, no, yeah.
Okay, the next thing we want to do is to learn how to copy strings. We want to learn how to copy a string into another string. How do we do that? How do we copy? We're going to use a function called, I don't think there's a way to pronounce, how do you pronounce this thing, but this is a function we're going to use. strcp. What's that? Okay, Maxwell, Nana, you raise your hand. Hello, Maxwell.
Yeah, you can hear me. So, canonically, it's just called string copy. So you can call it that.
What?
I'm saying that it is called a string copy.
Okay, you
Right?
said, okay, you say it's called a string
String
copy.
shortened and copy shortened. So we call that string copy.
Okay,
Yeah, exactly.
thank you for that. All right, so we're going to see how that function works. What the function does is the function copies from a source string to a destination string. So it returns the copied string. Let's say, for example, let's go back to our code again. Try to be smart about this. So it copies from what? It copies from a source. I'll call it SCRSRC to what? A destination string. Copy. If there was anything in that destination string, it's going to overwrite it. Do you understand, guys? So let's use an example now. Now I want to do that code. I want to see how we are able to copy. First of all, let's create let's call this one x1. Let's assign it to like 30. Let's set it to 30, size 30 equals to what? Let's say, what do I use now? Dialog. Dialog is important. Right? Now, we'll create another string. We'll create another string here. Call it x2. Who is raising hands, please? There's nothing here.
Yeah, it's me. Okay. Somebody did not ask the question before. So I was wondering, what if You know, the name you used for the last one we did now was for the reverse. It's in 7 letters. What if the name is eight letters? Will you still use that length divided by two?
Yeah, because it's going to stop where when the swapping stops, isn't it?
Yeah.
But the only thing is that there will not be a standing letter. Like in this case, there was a middle letter, but then there will be no middle letter, but it will still swap. So you could
Okay,
do
so we
that.
still use divided by two.
Yeah, you could do that when you want to see how it works.
Okay.
So I want to copy what? I want to copy x1 to x2.
Someone said you should check your second line. You did not put the hashtag,
Okay,
the
thank you.
hash symbol.
Thank you. Thank you very much. So then we're gonna use the function now, strcpy. Now we'll put the second string rather in first, which is the destination string x2 before we put the first string because we are copying from the source to the destination. Now, me personally, I always love to put this in a variable, right? Let me create another variable here. Create another variable here. Let's say this variable is y, right? You can say y is equals to what? This. Whatever that computes to, that's y. So then, printf we can do this. Look at this now. So you can see what we are trying to say. After this one, we can do something like this, printf. So you can see the difference. Right? Here's the contents of x1 the content of content of x1 is what x1 here. Yeah, you raise your hands. See content.
Yeah, Buzz, quick one.
Yeah.
Yeah, Godfrey, right?
Yeah.
Right. So you see that we are using the string copy function, right? And it returns um, a pointer to the string. All right. And then your car y is a character, not a pointer to a character. And you are storing the result of the string copy to the character, right? So this will be a problem because the string copy command will return a pointer to character. All right.
Okay.
You do what I'm saying?
Yeah.
Yeah. And it's been possible to not even store it inside of any variable because the destination will be copied. Like the source will be copied into the destination. So You don't need an extra variable to store the value
I know it's
that
not
you are
compulsory. Yeah, I
receiving
know.
from the.
I know you don't need that extra
Yeah,
variable,
yeah, yeah.
but I just wanted
Yeah,
to.
but
Okay, let's do it your way so I can see. It's the
yeah,
same thing.
I'm trying to point out the variable you put over there, the car y over there, like is not a pointer to a character.
Yeah,
So
sure.
storing, I don't know whether it's okay.
Yeah,
Yeah,
yeah, yeah.
that's what
You're
I'm trying to
you're
say.
correct. You're correct. There's no problem. I could do that. It's also given.
Yeah, but if you want, you could still put it in the y variable. But I'm just saying that then you would have to make that a pointer variable.
Yeah, but the what I understand, what you said is right. So, but another explanation for that is that the string copy function takes in two parameters. So if you try to put it into a particular variable and you want to print it out,
Exactly.
it's going to get confused as to, okay, which variable do you want me to print out? You understand? So except you are using it as a pointer. So I get you. You're right.
Yeah, so you could have made it a pointer variable and it would have worked. But previously it was just a normal character, which is 1 byte.
Yeah,
But
exactly.
if you should declare it as a pointer variable, then you could store the return value of the string copy inside of that as well.
Okay, okay. Thank you very much for that.
So,
So guys, let's run this and see. Zero. Okay. I need to add a new line. Anyways, so as you can see,
Are you sure you are not going to run it again?
yeah, this new line here, my dear, is where the problem is. All right. So the before we copied to x2, this is the content of x1. Dialog is important, and then we copied x1 to x2 so that the content of x2 now becomes this string. Dialog is important. So basically, you could play with the function strcp, so on and so forth, so I can see how it all work. Our boss will take us through at value. Okay, whatever that means. Anyways, so let's continue. Please, is there any question? Hello, guys. Any question, guys? Hello?
No question actually.
yeah,
Any question?
No question.
All right, in the absence of no other question, let us continue. So now we're going to work on other functions quickly. The reason why I'm going slowly is so that it can be clear. It can be clear for us, because if it's not clear, that's where the questions will start coming up, and it will be as though we are creating magic here. But the slower you go, the clearer it becomes, and it become better. All right. So now we want to work on another string. Another string function. This string function is strvp rok stro P. If I'm correct, I will check it up. B P B arrow P. Whatever this means, strip broke, whatever. Please, you need to take note of something. ALX will not ask you to use this function. ALX will ask you to create what this function can do. But if you don't understand what they do, that's where the confusion starts from. See, this function finds the first character in the string S1 that matches any character specified in S2. This is the syntax of the prototype of the function. So there's a constant parameter. Both of the parameters are constant, and they are pointers to what? They are pointers to strings. They are both pointers to strings. That's why there's character. They are pointers to strings. So the first string here, S1, the string to be scanned is S1, the first string. While the second string is the string that is containing the characters to match. So after it has done its manipulation, it will return a pointer to the character in what? S1 that matches one of the characters in S2. Else, it will return to null. So whenever I see else, I know that there's an if statement here. So we're going to work on that now. It's quite also not really difficult, but I'll make it as plain as possible. So let us use it. Let's just say find, because it searches for a particular character that matches something, that matches any character specified in S2. It searches the first string S1. It finds the first character in the string S1 that matches any character specified in S2. Right? So let us do it. Let us do that now. Mind you, we still have arrays to work on, and we still have ALX exercises to do, ALX projects for the next week to do. So I believe everybody is at home right now. I don't expect us to be going anywhere. Int main void, the main function, the most popular function in the universe. So now we're going to declare three strings, or rather, okay, let us declare three strings. But let me just use a very simple example. Let us use a very simple example where it will be easier for us. So first of all, let's declare a source string. Let me use this one as my source string. Let me say this one is what? S1, my source string. And I can use a number, I cannot use a number. Let me use 35. But let me leave it empty. And initialize it to what? Let me say repo. Now, if you look here, I've just typed the word repo. So the second string is going to contain one of these characters here. It could be arrow, it could be I, it could be P, it could be L, or it could be E. So once this first string is scanned by that function, and it finds out that there's a character in that function that corresponds to what the character in the second string, which is the second string I'm going to be writing now. Let me write a different string. This one is let me say of course there's nothing inside there. let's say which of the letters should I use now? Let me say I and 4, right? Now remember what I said, that what I said, that this particular function, which is strpbrok, returns a pointer to the character in S1, returns a pointer to the character in S1 that matches one of the characters in any of these other um, strings. S is going to return null. So I deliberately inputted these particular characters here, B29, because of course there's nothing here that matches B29. There's no match. But then put this one in S2. So we are going to see how that's going to pan out. But first I have to declare my pointers. Those of us that were not in the pointer class, I just hope we will be able to follow what we are doing now. Use arrow, use T. Right? Are we together, guys? Now we are going to assign.
We are together.
Okay. I'm going to show this guy how correct I was, but then let's leave it this way. You will see it now. That even though you use a variable, a function that takes 2 parameters, it can still return something. It has been created to return something. So you can do that. But then let's just leave it.
Okay, so I wasn't saying it was wrong. I'm saying that the variable you created wasn't a pointer variable.
Okay, yeah,
All right.
that's true. I remember. So okay, S2. Okay, S1 is the source one. So the S2. Second one is T equals to what? STRO PBRK S1 S3. I'm just trying to be faster. Then right now it now contains the return value for it. Like arrow now contains if it's null, or it's going to contain the character that matches the character in S2 that matches S1. That's what it's going to return, or null. So to make that happen, we can use the if statement to say, we can say that what if arrow is not equals to 0, not equal to, think yeah, if arrow is not equal to 0, that's what we'll do. Let's say printf output now. This is a landslide. Else and see what try again next time. as if r is not equal to 0. If it doesn't return a null, you do this. But if it returns 0, you print try again next time. You see that? Then we'll go to the next variable. If t is not equal to 0, do this. Congratulations. You are the winner. This is a lottery example I was talking about at that time. You are the winner. Else, you can say printf better luck next time. And that's it, you return 0. So let's say it's going to work. I hope we didn't make any errors here. I hope we are together, guys. Please don't get lost. All right. Try again next time. Congratulations, you are the winner. So the first statement amounted to null, and that's why I printed try again next time. Because why? When the first string was scanned to see if there's any character to match with the second string, they did not find any matching character. So that's why they said try again next time for the first person, but the second person is the winner because it was a matching character. So you can use it for a lottery application or whatever, password or something. That's what they usually use for password. The same logic. That's what they use for password. I'll tell you access granted, access denied. Yeah. They'll be looking for the matching character. We are creating those login forms or whatever it is that you want to create that will check for password. That's what they use, the same algorithm, the same idea. So we have seen the importance of that particular function. Let's go over the code again. First of all, we declared our header files, and then we declared the source, or you can say the target string, which is this repo. Now this second string contains character. The third string contains character. They will declare the pointer. The purpose of this pointer is to what? Is to get the return what? The return value of the function strpbrok. This function scans the first string to see if there's any matching character between both strings, both the first string and the second string. It scans the first string to see if there's any character in the first string that matches with any character in the second string. Then this also scans the first string to see if there's any character that is in the third string that matches with what? The first string. And it returns either null or it's going to return true. Now, we created this particular statement to help us know which of these string has a character that matches the string, a string in a character that matches a character in what? In the first string. So if you see here, we say if arrow, like this particular variable now, if arrow is not equal to 0, as if it returns true, print this. This is a landslide victory. Else, print this. So it's either it returns a particular value true or it returns not true. So if it returns null, if it doesn't return null, print this. Congratulations, if it returns null, print better luck next time. So that's how to use this particular function. Are we together, guys? Hello.
Yeah, we're together.
Okay, before we continue with strings, because we have done some things on string, let us go a little bit into arrays. Let us go into arrays a little bit before we continue with strings. Let me see people that are still around. Okay, Ajayi is still here, Zine is still here, Ahmed is still here, Tosin. Ayola, class rep. Has Ajayi gone? Ajayi has gone.
I think so. I think so.
Oh my God. Anyways, let's continue. So the other day we're talking about arrays. An array is what? An array is a collection of variables that are stacked together, or an array is a collection of elements stacked together and given a name. An array is a collection of elements stacked together and given a name. I don't know different levels, because some of us are joining us for the first time. Don't know if they have worked with arrays before. We're just going to do a simple operation with arrays though. Very easy operation. First of all, this is an array 1. String. Okay, no need the array, no need. So I'm used to this string stuff that now my brain has already collected it. Int main void. All right. So by now, I believe we already know what an array is. We already know how to declare an array and also how to initialize an array. We can initialize an array manually, especially when the elements are not really much. We can initialize an array using the for loop. We can initialize an array using a pointer to a file that will copy certain pattern or certain characters from that file and dump them in an array. So depending on how advanced you are, so depending on what you want to do, but we'll just do a basic operation here that will help us to insert a particular figure or an element in an array that we have already declared, an array that we have already initialized. We'll then go to edit it. We will go and insert an element inside of it. So first of all, let's start from scratch.
Oh,
Okay.
should I give us a question? Should I give us a question to work with?
Don't worry, Ayola. We're just trying to.
As an example.
We're just trying to make people understand.
Okay.
We'll treat questions later. Don't worry. After we have done all the explanation, then we'll start working on questions and exercise on the ALX and all of that. So,
Now, I'm not talking about your last question. I'm just talking about. We don't worry, sir.
so then let's continue now. First of all, let's initialize an array. Let's call this array x1. Set it to 35 equals to what? Normally we could just say something like this. So that's x1. We have initialized and all of that. Now we want to change a particular um, value. We want to change a particular value in our array. We want to change a particular value in our array to something else. How are we going to do that? Any ideas, guys? Maybe we want to change the value that is at position 4, which is 1, 2, 3, 4. The value at position 4. I want to change it to something else. How are we going to do that? Any ideas?
Maybe name of the array, then the index of the position we are changing equals to the new value we want to put there.
Okay, but if we put it here, if we put that now, what's going to happen? This particular value will be deleted. But then we don't want to delete it. Of course, you can actually just come here, just start saying x1, right? X1, what is it called? 1, 2, 0, 1, 2,
That's 3.
yeah, 3, right? And then assign something else to it, maybe so. You can do something like this, but that's not what we want to do. If we do that, we will lose this particular data, this 4 that is here, but we don't want to lose 4. So what do we do? How do we insert it inside?
Wait, so do you want to add to the 4 or what?
We want to add it to the array.
Okay, you want to add it to the array.
Yeah.
But it will be on that particular index.
Yeah.
I don't have an idea for that one.
Any idea, guys? Hello? All right, so let's just do it quickly. So that is where the logic of insertion comes. Inserting an element into an array. When you want to insert an element into an array and you don't want to delete it, first things first is that what? You have to what? Move the last element of the array. You have to move it. Remember, the difference between an array and a string is that what? Just like in a string, there's what? There's a null character that terminates at the end of the string, right? But for an array, it continues and continues and continues, and
I
it
don't
just
think
really
you can add the value for the array. That's good. Hello,
what?
can you hear me?
Yeah, I can hear you, Yasi. Yasi, I can hear you. Hello, Yasi. Hello?
I think it's gone.
No, he's still here. He just muted his mic. I don't know why. So this is what we'll do. We need to what? Take note of what?
I
Position.
can hear you. Can you hear me?
Yeah, I can hear you now. I can hear you. I can hear you, Yasi. I can hear you. What was your question?
I'm in mute again.
Saying, I was saying that the one.
Hello? Okay, let's continue. So, because we're going to work with position, because we need to know what position the array in question, the element in question is, we'll have to assign a variable for that. And then also, we'll have to assign a variable for the number that we want to put in it. So we can just initialize on the go and say, let me say we want to put number 15 in that particular spot, right? And the position that we want to include that is position 4. Let's say 5. Right? So what we need to do, we can say this. We can say for, I use a for loop. I say for I equals to the size of the array minus 1. What's the size of the array?
35.
Let's assign something here. Sorry. Well, we didn't use all of them. The size of the work. There's a difference between the size is actually 35 though. But I'm trying to prevent the situation where if we start shifting from the end of 35 and start coming backward. I wanted it to just be exactly from 8, but no problem. Let's just go. Size is equals to what? 35. Right? So we can do that here. So we can see for I equals to size minus 1. You know you're working with indexes, right? Size minus 1, 35 minus 1 is 34. So which means it's going to end at 34 and start from 0. So we're going to start from where we want to do the change. Check if I is greater or equal to what? Position minus what? Minus 1. So if you look now, position here is equals to what? 5. Right? Position is equals to 5. If you subtract 5 minus 1, what do you get? 4, which is 1, 0, 1, 2, 3, 4. This is where I want to make the change here. 0, 1, 2, 3, 4. So this is where we are targeting. These are target elements. So starting from here, right? We're going to check if I, starting from the last element, size minus 1, we check if I is greater than or equals to what? Position minus 1, which is here, 1 0 1 2 3 4. So if it's true, then we'll do what we want to do. You see it now. Let's increment this first. I'm sorry, decrement this because it's coming from back. Right? So now, what we're going to do now is to go to a position like this. Let's say I plus 1. That is the index I, the first index, the first element, first index. I plus what? Plus 1. Know that at this particular position, at this particular place now, I is equals to size minus 1. I is equals to what? Size minus 1. Look, 30 what? 35 minus 1 is 4. Is 34, right? So what we want
Yes.
to, yeah. So what we want to do now? We want to assign the element as at that point, which is 34, to the next element, 35, because I plus 1 is what? 35. If you look by the ordering of the index number starting from 0, even though you declare the size of 35, your elements will end at what? 30 what? 34. Are we following, guys?
Yeah.
Your elements will end at what? 34.
34.
Now, in your for loop, we are starting from the last element, which is 34, which is size minus 1, 34. And we are going to stop our iteration here at the particular position we want to insert our what? We want to insert what? Our element. So what is happening right now here is that we are going to assign the particular element that is at this particular position right now, which is 34, to what? To 34 plus 1, which is 35, which is the next cell after 30. That is, we are pushing 34 forward. We are pushing 34 forward from 34 to 35. So that there will be space. Do you understand what we are trying to do? So we are pushing 34 forward to 35. We created, what happened here is that we created a new cell, a new index now. Look, I is 34, right? I plus 1 is 35. Now, this element here, when I is 34, or this cell here, whatever it is that is here, when I is 34 now, we are assigning it to what? Element, to what? Index 35. Let me show you graphically what we are doing so that you guys will not be confused. This is what we are doing here. Right? This is how it looks like. Now, our work ends here. 34. From 0 to 34. This is the last cell, the last bus stop. When we do something like this, x1 in that our code, x1 I plus 1, x1 I plus 1 equals to what? x1 is a variable, is the name of the variable, so don't get yourself worked up about what it is. x1 I. What we are doing here is that we are inserting this particular element, which is the current which is at the current cell 34, because now I is equals to, in our for loop, I is equals to what? I is equals to what? I is equals to what? Size. Our size is 35.
-1.
I is equals to size minus 1, which is the index, right?
Yeah.
I is equals to size minus 1. That's what I is. So at this particular point in time, the index here is what? 30 what? 4, which
4.
is this particular position. So what we did now in this place, we did I plus 1. We created a new cell, 35, because I is 34 plus 1 is what? 35. Then we shifted whatever it is that was here into the new cell. Are you seeing this? So
Yes.
if, for example, a number, maybe number 9 was here, we shifted number 9 from here into this place, so that
Number 10.
so that here will become 9. We
Okay.
pushed 9 this way, so that here will become 9. Then this place will become what? Empty. Are you seeing this?
Yeah.
So as the for loop iterates, it will keep on pushing and pushing the numbers, because we don't want to delete.
Forward.
Yeah, if we're pushing it forward, we don't want to delete we don't want to delete anything. We don't want to delete that number that we want to displace. We want to push it forward and insert our own number in it. Do you understand the concept?
Yes.
So that's what we did here, and that's what this follow will be doing till it reaches here, this endpoint position, which is 5 minus 1, which is 4. 0, 1, 2, 3, 4. So this is particular position here. I want to display 6. 6 will now be moved to 7, so that we'll insert what? Our element there. So we can say x1
Oh, thank God.
position minus 1 equals to what? No. Increment size. Now we are okay like this. Let us see what happens here. What's wrong with this thing? For I, you can see for I equals towards 0. I want to print out this thing so I will see what's going on. For I equals to 0, check if I is less than or equal towards what size are we going to use now? Is 1, 2, 3, 4, 5, 6, 7, 8, 9. So size minus 9. Ayola, are you there?
Yes. Yeah, I'm there.
The purpose of this thing that we are doing is to make people understand what they are doing. Do you understand me? if it's to answer, there are billions of questions, billions of exercises that are all over the place that your brain would be like, that's not the purpose. The purpose of here is to understand, is to make people understand, okay, this is what this is what that is, this is what that is. And then maybe we'll do one or two questions, and then people can grab. Even all this one we are doing is actually questions that have been solved. You understand me? So that people can actually grab,
Yeah.
this is what's going on, this is what's going on. So it's not really, yeah, if you want questions, ALX is enough. There are questions in ALX. Your brain will turn upside down. So, but that's not the reason why we are here. So we can print off what's it called? I think the digits. Let's see what changed. Let's see what changed. I don't know. Usually if I put that in character, it doesn't give me any issues, but let's see, sure. I'm expecting some errors here, but gosh, let's see how it goes. This is original. This thing, I've not done this before. Okay, so I is undeclared. Okay. So, hello guys, do you know why I showed 0? Our sacrifice was not accepted.
Mhm.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Do you know why it showed 0? It showed 0 because our initialization was not right. So we can do something else. We can initialize it. I always prefer the for loop when initializing. So we can do something like this. Do something like this. Time has gone. So let's say F right. Then we can use the scanf to read whatever it is that you enter. Let's remove this size since whatever it is that you enter will then be the size. So there's no need for that. So we can say scanf and operator size. Comment say printf. Enter position you want to fill. Position, right? So we need to put this one here. You can automate it to become something like this. So you can fill whatever I want to fill, and then you can have it print that one. Okay. Let's see. Why did you just enter one? Hey. Oh wow. Sorry guys, I'm just encountering some errors here. For I equals to okay. I'm supposed to do a loop here that will take I'm supposed to do a loop here that will take as much as I want. Check if check if I is less than or equal to let me say 10. We use 10. Increment I. So it should work. But now I want it to be in my to be in this particular stuff. So in that position, okay, it should go. Problem now is size. I'm trying to see where I missed this. Probably is when I was initializing my arrays. But I don't want to confuse all of this stuff now. So that's why I have to look at this very well. So position is okay. Then enter your data. Data enters into here. A size. So we can come in now to actually initialize size. All right, let's run. See. So you can put as many numbers, put up to 10. Enter position. Position we want to do is what? 5. No, not now. Now, what's going on? Ayola, yo, what do you think I missed here?
I'm not sure. Let's look at this first.
Okay. There's something that I'm not doing right here. I'm trying to find it now. Or maybe I should just start all over again. Please hold on, guys. This thing is becoming too, has become too noisy for me. Enter. Oh. Data you want to insert. The data we want to insert is a particular number that I want to insert in our array. Do you understand? So the data we want to insert is particular number we want to insert in our array. So first of all, we have to ensure that our array is being initialized very well. I think that's where we start. That's what caused the problem.
What about if we not add any size when initializing our array?
Yeah. So it's the initialization of the array that is the problem. So we can just say something like this. Just say something like this. First, we will initialize our array this way. Int array. Let's name it array. Let's don't put anything. Right. Let's say printf. Enter your data. The for loop. I say for I, I'm not even declared I yet. So the next thing is towards declare I, which is your index. So you can say for I equal to 0. So the limit of the numbers of elements we want to work with is, let me say, 10, or let's say 5, for example. Check if I is less than or equals to 5. You increment. Increment. So what are we doing here? We are reading in the data. Scanf. Being an integer, and we are saving it into our array. So that's what we are doing there. So after that, you can say enter the data you want to the data that we want to change, that we want to insert into the array now. You can come in and say okay, enter the data to insert, data to be inserted. Divide this. So let me create another variable here. Int num. So int num will be the data that I want to insert. Remember, guys, what we are doing is we are trying to insert a particular element into our existing array. It's quite a technical task. So once that is done, you read it in using scanf. I don't think this thing will be here. It should be in the scanf list. Right, so read it into this particular variable. Now after that, we have gotten our number. Now we need to know the position. We need to know
sorry, I think the scanf of our array is missing the I.
we didn't put any I here. If you put I here, look, if you put I here, it will create another issue. There's no I here because why? When we're declaring it, we didn't declare it with the size. It's unlimited. Look at it.
Oh, okay.
Do you see that? So whatever it is that you are putting now, you just go in.
Okay, I
Do you
get.
understand?
Yeah.
So then, what to do? We can then say, okay, we need to know the position. So I'll come here and say printf again, the position that I want to insert that element in. Say enter position. Again, you read it in. Position. So we'll come here now. And we'll do what? We'll create this position. Please take notes. So I think for now we're okay. Oh, let me just do this. Let me just create this. Let me add this, right? For simplicity's sake. So I think it's okay. So now, but with this now, we'll be able to get our number and we're able to get our position. So now, what we want to do is to insert the element into the array. So we'll come here, I will say for, I use a for loop again, because remember what we explained, I will be shifting what? We'll be shifting the last element in the array.
To a new one.
Yeah, to a new one. We'll be shifting
A
it to
joint kind of.
yeah. So we'll be shifting it. So we can say for I equals to 10 minus, or let's start with 10. I don't know. 0 1 2 3 4 5 6 7. It's not known. Let me include it. Let me include it in the size so it can be movable. So let's say size minus 1. Size of the array is 10. So I say for I equals to size minus 1, which is the last one. Size minus 1 is 9. Check if I is what? Is greater or equal to position minus 1. Position minus 1, there is index. The index I want to work on. What do? You decrement I, because it's starting from the back to the forward. It's pushing them forward. So then our array name is this. Create a new cell so I can push those guys forward. I plus 1 actually. This thing is very important. I guess we'll see the importance later. A array.
You put the wrong bracket.
Yeah, I'll change it. Where's that guy that was talking about pointers that time? He just left.
He already left.
So when that is done, once we have been able to shift the last to a new array, to a new cell, but this one is like creating a new cell in the array. So this now we will insert the last one, because when I is size minus 1, that is 10 minus 1, 9, right? Shift it to what? I plus 1. So 9 will go to 10. And when this decreases rather, when I decreases to 8, it will do the same thing here. Guys, are you following, please?
Yes.
Is the only one person that we have here?
Yes, I'm following.
Ahmed, what's up? Ahmed.
I'm fine, I'm fine.
Okay, so let's see. I just hope this works.
We are following.
All right. So position -1 is the index. Position is what? Whatever it is that we'll put it. We have not yet done that yet. So position -1 will be the particular position that we want to do. We want it to work on. So position -1, okay, will be equals to num. Remember that information we want to insert in the increment size. The only thing I'm skeptical about here is this particular thing, here, size. For I is equals to size -1 check if I is greater or equals to position -1. That's of course where it's going to end. Decrement I. So I is being initialized with what? 9, right? And then it will decrease to 0. Okay, we are okay. All right, we're okay. So size plus. Now, in case the user, what about a situation where the user wants to insert into how do I put it, into an illegal position? What are the illegal positions here? Okay, nobody's answering. So let's do something like this. Illegal positions are
The first time I'm hearing about illegal position.
This guy will not kill me out. Very hilarious. Of course, there are illegal positions now. Like positions that are less than 0, for example. In the index now, any position that is less than 0 is an illegal position. So if you want to go
Okay.
and put in 0, it's an illegal position. And
Sorry.
for any position that is greater than size +1, we will not accommodate any position like that. Although this is not really necessary, but I'm just putting that thing there.
Okay.
What do you do? Printf. Insert invalid position. So then I think we have some lines of code here. Just hope it works out fine. So these are code. We want to insert a particular number into an array, and we don't want to start, even when we want to enter the data, we don't want to start initializing manually because we don't want it to be stressful for us. We tried it the first time, saw how it worked rather, but now we just hope it goes well. So let's run our code. I'm still skeptical about something. I don't think we included printing. When it has finished shifting it, we need to print it out. Okay. Right. To print it out, we still need another for loop. Can you just imagine? That's scale. This thing is something else. To print out your y, you need to do another for loop to print it out again. For I equals to 0, check if I is less than or equals to what? Size. Increment I. Right? F. Printf, what's it called again? Hope I got that all right.
I think we have two mistakes in our code.
Okay. What are the mistakes?
For the first four statements, R is supposed to be less than or equals to 10, I think. Okay, you
Yeah,
put the other one.
we just wanted 5.
Okay. Okay, you created the other one. The other one was size plus plus the semicolon. You've added that one already.
We just wanted 5 elements. Let's see if there's any error, then we'll run it again. See. So 32, 45. The data to be inserted, take notes. Let's say 100 so that it will be very easy. Enter position 4. Where is it getting all these plenty numbers? Okay, look, these are the elements 32, 45, 34. He inserted 100, 67, and 54. But he deleted 24. So let's go and
I
check.
think that was because we did position minus 1 or something like that.
Yeah, let's go and
And for the plenty number, is because we did not, I think just added garbage value for the rest.
What?
I think he just added garbage value for the
Yeah,
rest.
yeah.
That's the
For the
plenty
rest,
number, blah blah blah.
he did what is called padding. What he did is called padding. Just put something there
Mm.
so that place will not be empty.
Not hearing you.
Position -1. If I check if I is greater than equals to position -1. That's where it stopped.
I
Okay,
think
so
this is where we did the mistake. Yeah, yeah, where you're pointing, where you're pointing right now.
this one, right?
Yeah.
No, this particular place is what actually assigned number, that is that on 100, to position. Position is what do we put in position? 4, right? 4 -1.
Yeah, so he did 4 - 1, so you're assigned to the third position instead of the fourth position.
Okay, okay. So if we wanted the fourth position, we should have used 5. All right, but then let's go. So basically, that is actually how you insert a number into an array. If we tweak our code a little bit now, and if we change this particular place, this size to 5, maybe it will become much more better. Maybe it will become much more better. Let's see. Data to be inserted, the same 100, enter the position. Let's say 3. 5, 4, 100, 10, 44, 45. Anyways, don't worry, we'll tweak that later. Let me just understand a little bit. But this is how you insert a number. Then maybe we'll meet again. I want to talk about how to. I will definitely.
So can you show us the code again? So we'll try to run some things on our own.
So yeah, this is the code.
Okay, let me just snipe it. A minute.
But let me copy it and paste.
Okay, that's good also.
So I've pasted it there. So let's continue.
Thank you.
We have done pretty a lot. We have done quite a lot of things here.